Alright, this is a video for Exam 1, page 4, section 2, and we'll get started right now. Use the provided graphs of f of x and g of x from page 2 to answer the following questions about continuity. You must use proper mathematical vocabulary and notation in your explanations. If a function is discontinuous, classify the type of discontinuity. So question 1, is f continuous at x equals 5? Explain. So we'll go back to our graph for y equals f of x. And as we can see, for the limit at x equals 5, our left-hand limit seems to be 3. Our right-hand limit seems to be about negative 1/4. And our x value seems to be at f of x value for 5 seems to be negative 3. So in this case, we can see that the function is not continuous because these three points are not the same. So, and because we can see that there are different points, we can see that this is a non-removable jump because we have 3 different jump points that at the same position. So we will say that f is not continuous at x equals 5 and has a removable non-removable. Should we write that? Jump at x equals 5 because, and we need to show in mathematical form that these 3 things are not equal. So limit of x approaching 5 from the negative side of f of x is not equal to limit of x approaching 5 from the right of f of x does not equal f of 5. And just for extra measure, we will show what these 3 values equal so we can make it clear why each of these are not the same. So just a double check, left hand limit at x equals 5 is 3. So we'll put limit of x approaching 5 from the left, f of x equals 3. Limit of x approaching 5 from the right of f of x equals negative 1/4. And finally, f of 5 equals negative 3. Alright, now for our next question. Is f continuous at x equals 9? Explain. So we'll go back to our f of x, and as we could see at this value, we could see that the left side of the graph seems to be going to negative infinity, and the right side of the graph seems to be going to infinity. And so these two graphs are not approaching the same value, and there is no value at for at f of x, f of 9. So in that case, f of x, we'll write it a bit differently. I like writing things a bit differently so they're not exactly the same as the previous answer. Just something I prefer. Is not continuous. Let's see, let's rewrite that. Oh yes, and because these two are approaching infinities, we have an infinite discontinuity. So we're gonna add is as in non-removable infinite at x equals 9 and is not continuous because once again we need to show that these three values are not going to be the same. So we will put that limit of x approaching from the right of f of x equals, we'll double check, negative infinity. Accidentally wrote plus. Yes, I also almost forgot to write this form. We'll just do it above here. Limit x approaching 9 plus f of x equals f9 squared. That, and let's see. Now we can show this. So 9 positive f of x equals infinity. And finally, because there is no f of 9, we'll put that f of 9 does not exist. And that's all for these two questions. Alright, and so I will now end the video. Alright, bye.